All right, today you're going to need your notes. We're going to do a little preview of some stuff we're going to get into before we actually do chapter 8. And you're going to want to write this down because the first few days you're probably going to refer back to this stuff quite a bit. As you get more familiar with it, you won't need to look back quite as much. But early on, you probably will. And this is something we're going to do a bunch of next year in Algebra 2. So it's kind of a little preview of what you're going to get into next year with Algebra 2. In fact, Chapter 8, all of Chapter 8 is kind of a preview of stuff you're going to do next year when you go to Algebra 2. Chapter 8 is over trigonometry. We're going to get into the real basic parts of trigonometry. And then next year in Algebra 2, you'll expand on those basic parts that we're going to do this year. Now, before we get into the actual trigonometry, we have to be able to put some things in different types of forms to give the answer that they're looking for. So the first one they're going to ask us for is for us to write something in simplest radical form. And simplest radical form is going to look different than what you're used to doing. And it's all going to revolve around what we call the perfect squares. And these perfect squares are something you already know. This is probably the one part of today that you already know. But it is something you'll have to make sure you remember for the test, because this will not be given to you. The perfect squares are when we take a number and we square it. Like 1 times 1, we get 1. Well, if you go backwards, the square root of 1 would be 1. And the reason for that is just like what I just got done saying. If you square 1, 1 times 1 is 1. So if you go backwards, the square root of 1 is 1. And we're going to go all the way down the line here. Square root of 4 would be 2, because 2 times 2 gives you 4. Square root of 9 is 3, because 3 times 3 gives you 9. We're going to put a bunch of these up here. Square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And square root of 144 is 12. This year, we probably won't go any higher than that. Next year, you probably will. But for now, this is going to get us through what we need. So what I'm going to do is circle this first column. This first column is what we're going to call the perfect squares. And we're going to use those perfect squares to write things in simplest radical form. So here's an example of simplest radical form. This is going to remind you of factoring, factor trees back when you probably did that, I don't know, 3rd grade, 4th grade, whenever that was. They're going to give us a number that's under the square root symbol, the square root of 20. Now, if you wanted to, on your calculator, you could go in and you can put that in your calculator. I'll let you see this on the screen. I put in 20 and then I hit the square root button. I get 4.4721359. Do the numbers stop at 9? No, they keep going. So is this number exact?
No.
No, this is no longer exact because the calculator had to round it off. So what we want to do with simplest radical form is we want to keep the answer exact. And that's what you're going to be doing next year in Algebra 2. They want the answer to stay exact. We don't want to be rounding things off into a decimal. So to do that, we're going to go back to, like I said, kind of like factor trees. We're going to split this square root of 20 up into 2 numbers that you can multiply together to get the square root of 20. Both of those numbers are going to be under the square root symbol. And we'd like one of them to be a perfect square.
4.
Now I'm going to take out 1 because 1 is a factor of everything. Everything can be multiplied by 1. So we're going to kind of toss that out. But what we want to do is find another perfect square that's going to be a factor of 20. Aldine, what'd you say?
4.
Square root of 4 is. Square root of 4 is going to be a factor of 20 because you can take 4 times 5 to get 20. So the square root of 4 times the square root of 5 will give you 20, or square root of 20. And then I can simplify this square root of 4. We said the square root of 4 equals 2. So the square root of 4, I can simplify down to 2. Square root of 5, there are no perfect squares that are a factor of that, other than 1, but we're throwing 1 out. So this is my answer in simplest radical form. 2 times the square root of 5. That's still an exact number, whereas in the calculator, that's a rounded off number. That's the reason we're doing the simplest radical form. And you're going to have a lot of answers next year that are going to be in this form, so you want to get used to this. Let's try another one. Let's take the square root of 18. Once again, I could put that in the calculator and get a decimal approximation, but we want to keep the answer exact. So we're going to do our factor tree. Square root of 18, we're going to split up into 2 square roots.
9.
We want one of them to be a perfect square. Yep, 9 would be a perfect square. That's a factor of 18. 9 times 2 gives you 18. And we know the square root of 9. Square root of 9 is 3. So I'm going to replace the square root of 9 with 3. Square root of 2, there's no other perfect squares that are a factor of 2. So we're going to leave it as 3 times the square root of 2. This third one I'm going to give you could be done 2 different ways. The square root of 32. And I'm going to show you both ways just so you know you can do it either way. Square root of 32, we're going to split that up into 2 perfect squares, or into 2 square roots. One of them is going to be a perfect square. Can anybody pick out a perfect square that's a factor of 32? Yep. 4 would work. 4 times 8 gives you 32. And we know the square root of 4. Square root of 4 is 2. The square root of 8, though, I can still break that up. There is a perfect square that's a factor of 8. What is it?
2 and 4.
4 again. So I can break up the square root of 8 into the square root of 4 times the square root of 2. Because the square root of 4 times square root of 2 gives you the square root of 8. Square root of 4, again, we know is 2. So I'm going to replace that square root of 4 with a 2. So I've got a 2 out front. Square root of 4 becomes a 2. And I've got a square root of 2 behind it. If I put that 2 times 2 together, I get 4 times the square root of 2. There it is in simplest radical form. Now, there's another way to do that. So let's show you this. Square root of 32. We're going to split it up into 2 square roots. One's going to be a perfect square. There's another perfect square up there that's a factor of 32 other than 4. 16. 16 times 2 will give you 32. And we know the square root of 16 is 4. So this simplifies down to 4 times the square root of 2. We get the exact same answer either way. Which one's quicker? 16. So if you have 2 choices when it comes to perfect squares, which one should you pick? Pick the bigger one. If you go with the bigger one, you're going to get to your answer quicker. If you go with the smaller one, it'll still work. You're just going to have to do more work to get there because you'll have to break down the second number again. So if you got a choice, go with the bigger number. That will get you your answer quicker. All right, let's do one more of these. Let's take square root of 50. This is the true test to see if you're getting this figured out. We're going to break this up into 2 square roots. We want one of them to be a perfect square that's a factor of 50. Can anybody figure it out? Zachary?
25.
25 would work. 25 times 2 gives us 50. And we just did the square root of 25 up here. Square root of 25 is 5. Square root of 2, there's no perfect squares that are a factor of 2 other than 1. So we're going to leave it as 5 times the square root of 2. All right, that's good. Now, you know what answer I usually get when I say what's a perfect square that's a factor of 50? All the time, people say 10. Is 10 a perfect square?
No.
Nope, 10 is not a perfect square. Is 10 a factor of 50?
Yeah.
Yes, it is, but it's not a perfect square. So when you're putting these together, when you do your little factor tree, one of those numbers has to be one of these perfect squares in order to break it down. All right, now, I don't know if I told you guys this, I told the last class. Some of you are gonna pick this up right away today. It's gonna make perfect sense, it's gonna be no problem. Some of you, it's gonna take a little longer to pick up, 2 or 3 days. Did I tell you that already?
I don't know.
You don't know? You haven't been here the whole time?
Yeah, don't know. Sorry.
Well, that's the thing. With this stuff, some of you are gonna pick it up right away. Some of you, it's gonna take you a few days. When we get into chapter 8, we keep doing this over and over again. Almost all of your answers are gonna be in this form. So if you don't pick it up right away today, don't panic. This is something you're gonna pick up as we go. We're gonna do it many, many times. How many think they got the hang of it already? Okay, that's a good sign. Now, there's a little bit more we have to do with this. If they change the directions to simplify, it's going to be the same kind of idea. We want to get our answer to the simplest form we can. Now, with this one, we're going to kind of go backwards. Before we gave you a square root, you broke it down into simplest radical form. Now we're going to give you 2 square roots that we're multiplying together. I'm going to take 50 times the square root of 2. And before we do this, I'm going to go back to our first problem. The square root of 20 we broke up into the square root of 4 times the square root of 5, because the square root of 4 times the square root of 5 gives you the square root of 20. If you multiply the 2 square roots together, you multiply the numbers underneath, that goes underneath the square root, and then your square root symbol goes to the top, stays over it. Same thing will happen here. You're going to multiply your numbers first. 50 times 2 is 100. And then that square root symbol is going to stay on top of it. Square root of 50 times the square root of 2 is the square root of 100. And this we can simplify. We know the square root of 100. What's the square root of 100?
10.
10. So your answer, simplest answer here would be 10. Let's try the square root of 8 times the square root of 2. Once again, you're going to multiply the numbers underneath. 8 times 2 is 16. Square root symbol is going to stay on top of it. We know the square root of 16. What's that? 4. That is 4. Sometimes they're going to put a number in front of the square root symbol. Let's say we have 3 times the square root of 5 times 2 times the square root of 2. And before we do this one, I'm going to take you back to algebra. Last year, when you had algebra, let's say we had 3x times 2y. Anybody remember what you get when you take 3x times 2y? I forgot this part. We're going to multiply the numbers first. 3 times 2 is 6. X and y are different variables. When we multiply them together, we can't combine them, so we just keep it x, y. Same thing's going to happen here. You're going to take your numbers out front, multiply them together. The numbers out front are 3 and 2. 3 times 2 is 6. Your x and y this time, we can multiply together. Square root of 5 times the square root of 2. What's the square root of 5 times the square root of 2?
10.
Not just 10.
Just 10.
Square root of 10. That square root is important. You're going to have that over the 10.
Square root. Okay.
Now, if you go back to your perfect squares, is there a perfect square that's a factor of 10?
No.
Nope, other than 1, but 1 is a factor of everything, so throw that out. This is as far as we can go. Let's do one more of those. 5 times the square root of 3 times 2 times the square root of 6. All right, same deal. Multiply your numbers out front. 5 times 2 is 10. Then you multiply your square roots. Square root of 3 times the square root of 6 is the square root of 18. Is there a perfect square that's a factor of 18?
Mm-hmm.
Yes, what is it? 9. So we can break this apart. So let's do that. We're going to keep our 10 out front. Square root of 18, we're going to split up into 2 square roots. 9 was our perfect square. 9 times 2 gives us 18. We know the square root of 9. What's the square root of 9? 3. So I got a 10 out front. Square root of 9 becomes a 3. Square root of 2 behind it. We can't simplify. And if you multiply your numbers, 10 times 3 is 30. Got the square root of 2 behind it. Square root of 2 can't be simplified, so that's your simplest answer right there. 30 times the square root of 2. Okay, do we need to see more of those, or are we ready to move on? Raise your hand if you need to see more of those. Okay. Number 9. I'm going to give you a little bit of a shortcut. This shortcut, you can get by without knowing the shortcut, but this is going to save you some time when we get into the next thing we're going to do. Our shortcut is going to look like this. If I have the square root of 5 times the square root of 5. We know how to do that at this point. When you multiply square roots, you multiply the numbers underneath first. 5 times 5 is 25. Square root is going to stay above it. And we can simplify square root of 25. What's that? That is 5. So the square root of 5 times the square root of 5 is 5. Let's do the square root of 3 times the square root of 3. Square root of 3 times the square root of 3. Multiply the numbers together first. 3 times 3 is 9. Square root symbol stays above it. Square root of 9 can be simplified. What's that going to be? 3. So the square root of 3 times the square root of 3 is 3. Now, we'll see if you can see the shortcut. Square root of 7 times the square root of 7. Can anybody get me right to the answer?
49.
It's going to be 7. Square root of 5 times square root of 5 is 5. Square root of 3 times the square root of 3 is 3. Square root of 7 times square root of 7 would be 7. What would the square root of 16 times the square root of 16 be?
16.
16. If you can remember this shortcut, that's going to save you some time as we get into some of the stuff we're going to do later on. Okay, last thing then. Again, we're still under the directions of simplifying. This time we're going to give you a fraction. I know you guys don't like fractions, but these actually end up being easier than the fractions you're used to doing. We have 8 divided by the square root of 3. Now, back in the olden days, back when I was taking geometry in high school, if you put this number into your calculator would say error. Because back in our day, there was no way to divide by a square root. This was something that was just undefined. We couldn't do it. Okay, nowadays, if you put this in your calculator, we've advanced enough, we can get an actual decimal equivalent for this number by putting it in the calculator. But because back then we didn't have a way of doing this, we had to come up with something else that would give us an answer that was equivalent. So we want to get rid of that square root of 3 in the denominator. If I multiply something times 1, do I change its value? No. If I take 6 times 1, it's still 6. If I take 10 times 1, it's still 10. I'm going to multiply this number by a fraction that's equivalent to 1. And we're going to go back to what we just did up here. I want to get rid of the square root in the denominator. So that square root of 3 down there, if I multiplied it by the square root of 3, I would get 3. So what we're going to do is we're going to make a fraction equivalent to 1 that's going to contain that square root of 3. I'm going to put square root of 3 on the bottom. The fraction that would be equivalent to 1 would be the square root of 3 over the square root of 3. Anything divided by itself is going to be 1. So this fraction right here is simply multiplying by 1. It doesn't look like it, but that's what I'm doing. I'm multiplying by 1. And once again, if you multiply by 1, do you change the value?
No.
No. So our answer is going to look completely different than what we have here, but it's still going to be the same value. Now, once I get to this point, it's just a matter of multiplying across. 8 times the square root of 3 is 8 times the square root of 3. And do the shortcut on the bottom. What's the square root of 3 times the square root of 3?
9.
Square root of 9, which is?
3.
3. So if you just go right to your shortcut, square root of 3 times square root of 3 is 3. 8 and 3 cannot be divided by the same thing other than 1. So this is going to be our answer in simplest form. Let's try another one. Let's take 11 divided by the square root of 2. Back in the glory days, back in the 1990s when I was in high school, actually I was in the 80s and the 90s, we would see this and we'd kind of freak out. Can't have a square root in the denominator. So we're going to multiply by a fraction equivalent to 1. That fraction is going to contain the square root of 2. So that fraction will be the square root of 2 over the square root of 2. Right there, I'm multiplying by a fraction equivalent to 1. It's not going to change the value, but it is going to change the way things look. 11 times the square root of 2 is 11 times the square root of 2. On the bottom, you got square root of 2 times the square root of 2, which is what?
2.
2. 11 and 2 can't be reduced, so we're going to just keep it right like that. Now let's show you one where we can reduce. We'll run into those also. Let's take 10 divided by the square root of 5. Okay, once again, you see a square root in the denominator. We can't leave it like that. That causes us issues. So we're going to multiply by a fraction equivalent to 1. Can anybody tell me what the fraction is?
Square root of 5.
Square root of 5 over the square root of 5. There you go. We do that, you get 10 times the square root of 5 on top. On the bottom, you got square root of 5 times the square root of 5. Shortcut tells us that's going to be 5. Can 10 and 5 be reduced?
Yeah.
Yes.
Yeah.
What can they both be divided by?
25 and 2.
Not 25.
5.
They can both be divided by 5. 10 divided by 5 is 2. 5 divided by 5 is 1.
Oh, wait, yeah.
So this is going to become 2 times the square root of 5 over 1, or you can just write that as 2 times the square root of 5. If you want to put the 1 on the bottom, you can, but usually we just leave it like this.
I was just thinking 10 times 5, sorry.
Oh, you're going to multiply it. All right, let's give you one to try all by yourself. No help on this one. This one's all by yourself. We have a square root in the denominator. See if you can get that to simplest form. All right, these look good. You may want some more time to finish it off. Okay, first thing we gotta do is figure out the fraction we're gonna multiply. We have a square root in the denominator, square root of 6 in the denominator, so I'm gonna multiply by square root of 6 over the square root of 6. When I do that, on top we get 18 times the square root of 6. Denominator, square root of 6 times the square root of 6 is 6. 18 and 6 can both be divided by 6. That would get us down to 3 and 1. So our answer in simplest form is 3 times the square root of 6. Any questions on how I got to here? Okay, now I said it's going to take some of you a few days to figure this out. If that's the case, don't panic, you'll get there. How many think they got a pretty good grasp of it already? Okay, that's good. Well over half of you, so that's a good start. Okay, today we want you to just practice this a little bit. We got a real short thing for you to do. In your packet of stuff, if you open it up to the first page, we have a Pythagorean theorem worksheet. We're going to do that. That's going to be tomorrow's stuff. But on the back of that, we've got 9 problems that deal with this simplest radical form. So we want you to do those 9. Just keep working on these. See if we can get them figured out. And again, if you don't quite have the hang of it yet, just keep working at it. You'll see a bunch of these and get it before long. If you finish this today, we'll go ahead and put it in the grade book so you can bring it back if you do. The rest of the time is yours to get to work on there.